Welcome students, welcome to the video class. Today we will discuss the topic that is magnetic field due to a bar magnet at any axial point. Axial point को हमें end on position भी कही परिवा. ठीक है. Again, today we will discuss magnetic field due to a bar magnet at any axial point. ठीक है. Before starting this topic, we should discuss some important things. Again, I just want to say you this topic magnetic field due to a bar magnet at any axial point is a long question in this chapter. Is a long question in this chapter. ठीक है. Okay. तो आमे इलेक्ट्रोस्टैटिक रे पढ़ीचे कि a charge produce electric field around itself. A charge produce electric field around itself. If it is a positive charge, the electric field is outward in nature, or the direction of electric field is outward in nature. If it is a negative charge, the direction of electric field is inward in nature. ठीक है. तो यदि हमें गोटे पॉजिटिव चार्ज नबा at r distance from the positive charge, the electric field is outward in nature, or the direction of electric field is outward in nature, and the magnitude is 1 by 4 pi epsilon naught q by r square. यदि हमें negative charge नबा at r distance from it, the direction of electric field is inward in nature, and the magnitude is same, that is 1 by 4 pi epsilon naught q by r square. Again, a charge produce electric field around itself. If it is a positive charge, the direction of electric field produced by it is outward in nature. If it is a negative charge, the direction of electric field is inward in nature. यदि positive charge थियो at r distance from the positive charge, the direction of electric field is outward in nature, and the magnitude is 1 by 4 pi epsilon naught q by r square. Similarly, यदि हमें negative charge नबा, direction टा inward आसिबो and magnitude समान रहबो, that is 1 by 4 pi epsilon naught q by r square. ठीक है. Positive पाई direction of electric field is outward, negative पाई direction of electric field is inward. ठीक है. Just like that, हमें magnetism रे पढ़िबा कि ए हमें जानिचे कि a magnet produce magnetic field around itself. A magnet produce magnetic field around itself. यदि हमें isolated north pole नबा, it produce magnetic field that is outward in nature, or the direction of magnetic field produced by isolated north pole is outward in nature. And यदि हमें गोटे south pole नबा, it produce magnetic field and the direction of magnetic field is inward in nature. ठीक. Again, a north pole produce magnetic field that is outward in nature, and a south pole produce magnetic field that is inward in nature. ठीक है. तो यदि हमें गोटे पोल नबा, isolated pole having pole strength m, and if it is a north pole, at r distance from it, it produce magnetic field that is outward in nature, and the magnitude of magnetic field is mu naught by 4 pi m by r square, where m is the pole strength, r is the distance from the pole. If it is a south pole having pole strength m, at r distance from it, it produce magnetic field that is inward in nature, and the magnitude is mu naught by 4 pi m by r square. ठीक है. Again, a magnet produce magnetic field around itself. यदि हमें isolated north pole नबा, it produce magnetic field that is outward in nature. The direction of magnetic field is outward in nature. Jodi ame south pole nova, isolated south pole, it produce magnetic field that is inward in nature, or the direction is inward in nature. Jodi gote pole nova, and if it is a north pole at r distance from it, it produces magnetic field that is outward in nature, and the magnitude is mu naught by 4 pi m by r square. Jodi south pole nova, at r distance from it, the direction is inward, magnitude is same, that is mu naught by 4 pi m by r square. ठीक है, एटा हमें यूज करिवा इन दिस लॉन्ग क्वेश्चन. ठीक है. नेक्स्ट इज हमें जाने चाहिए इलेक्ट्रोस्टैटिक रे यदि गोटे इलेक्ट्रिक फील्ड रे इफ ए चार्ज इज प्लेस्ड इट विल एक्सपीरियंस ए फोर्स. दैट फोर्स इज गिवन बाय F is equal to EQ. That force is given by EQ. Again, यदि गोटे इलेक्ट्रिक फील्ड रे गोटे चार्ज Q रखिबा, it will experience a force. That force is equal to EQ. ठीक है. If it is a positive charge, it will move along the direction of electric field, or it will experience a force along the direction of electric field. यदि negative थी, it will experience a force that is anti-parallel to the direction of electric field. काहेकि when you say electric field, यदि हम गोटे electric field a direction नबा, हमें जाने जे electric field they start from higher potential ends in the lower potential, or we can say they start from positive charge ends in the negative charge. So if the electric field are moving in this direction, एपटे higher potential थियो, एटा lower potential थियो, और एटा मोरो positive charge थियो, एपटे negative थियो. Because electric field move from positive charge to negative charge. So when this positive charge is placed in this electric field, this positive charge will be attracted towards the negative. So it will experience a force along the direction of electric field. ठीक है. यदि negative charge था तो it will be attracted toward the positive charge, force a direction था. ठीक है. Same, यदि हमें गोटे magnetic field नबा, and in that magnetic field we place a pole having pole strength m, so it will also experience a force. That force is given by F is equal to m into b, where m is the pole strength of the pole and b is the strength of the magnetic field. ठीक है. Okay. Again हमें जाने चाहिए कि when a magnetic field is there, magnetic field lines always starts from north pole ends in the south pole outside the magnet. Again, magnetic field lines always starts from the north pole ends in the south pole outside the magnet. So that means if the magnetic field is in this direction, तो एपटे north pole थिबो, एपटे south pole थिबो of the magnet. ठीक है. So when we consider a pole having pole strength m, and if it is a north pole, so this north pole will be attracted towards the south. So it will move, it will experience a force along the direction of magnetic field. It will experience a force along the direction of magnetic field. ठीक है. And the magnitude is F is equal to m into b. यदि हमें गोटे pole नबा, and if it is a south pole, this south pole will be attracted towards the north, so it will experience a force in this direction. ठीक है. आउ किछि टॉपिक डिस्कस करबा that will be used in this long question. ठीक है. The first one is ideal dipole. हमें dipole moment पढ़छे, that is equal to pole strength into magnetic length. Dipole moment of a magnet is equal to pole strength into magnetic length. If the pole strength of the magnet tends to infinite and the magnetic length tends to 0, in that case it is called an ideal dipole. Again, if the pole strength of the magnet tends to infinite and the magnetic length, that is 2L, tends to 0, in that case the dipole is called an ideal dipole, or an ideal dipole is a dipole whose magnetic pole strength tends to infinite, that is M tends to infinite, and magnetic length, that is 2L, tends to 0. ठीक है. Next आम मैंने just discuss करिथिले a pole, a magnetic pole produce magnetic field, and if it is a north pole the field is outward, and if it is a south pole the field is inward. A magnetic pole, a magnetic north pole having pole strength M at r distance from it produce magnetic field that is outward in nature, and the magnitude is mu naught by 4 pi m by r square. M is the pole strength of the north pole, r is the distance of the pole from the point, or of the point from the pole. If it is a south pole having pole strength m, then at r distance from it, it produces magnetic field that is inward in nature, and the magnitude is same, that is mu naught by 4 pi m by r square. ठीक है, just a revise कले किछ समय करे. तो आउटे कथा तो let us consider a magnet, bar magnet. This is the south pole, this is the north pole, and pole strength is m. The line passing through the two poles is called axial line. Again, the line passing through the two poles of the bar magnet is called the axial line. Any point lying on this axial line is called axial point. ये गोटे जदि पॉइंट नबा ए लाइन रे जदि गोटे पॉइंट नबा तो लेट अस से दिस इज कॉल्ड द एक्सियल पॉइंट. एटा भी हे परिबो एनी पॉइंट ऑन द axial line is called axial point. Similarly, the line which is passing through the center and perpendicular to the axial line is called equatorial line. The line which is perpendicular to the axial line and passing through the center is called axial line. Any point lying on this line is called equatorial point. Any point lying on this equatorial line is called equatorial point. ठीक है. So let us read the heading once again. It states that magnetic field due to a bar magnet at any axial point. So there is a bar magnet, let us say this, and you have to find the magnetic field at any axial point. Got an axial point number on the axial line of the bar magnet, and at that point we will find the magnetic field due to this bar magnet. That is the topic or the heading of this topic. So let us say this is a axial point of this bar magnet. So this is the north south pole, this is the north pole of the magnet. The pole strength is m. So if this is the axial point, ठीक है, तो हमें जानिए if a north pole is there, it will produce magnetic field. And the magnetic field is outward in nature. If there is a south pole, it will produce magnetic field that is inward in nature. So in this bar magnet we are having two poles, one is north pole and second is south pole. The north pole will produce a magnetic field at this point, that is outward in nature. Let us say this is B1. This north pole of the bar magnet will produce a, a magnetic field at this point, at this axial point, that is outward in nature. This south pole will also produce a magnetic field at this point. So it is inward in nature. So by using vectors, we will find the net magnetic field at this point, which is the heading of this long question. You have to find the net magnetic field at any axial point of a bar magnet. ठीक है? Okay. Again आउथरे टाको डिस्कस करिया भल से. Okay. So as per this question, again I am doing this. Let us consider a bar magnet. Let us consider a bar magnet having pole strength M. Let us consider this bar magnet. Let us say this bar magnet is AB. Again, let us consider this bar magnet AB having pole strength M. Having pole strength M. And this is the north pole of the bar magnet, and this is the south pole of the bar magnet. And the two poles are separated by a distance that is 2L. The two poles are separated by a distance that is 2L. ठीक है? So if this is the center रू south pole distance कितना हो L, center रू north pole distance मध्य L हो. ठीक है? Okay. So let us say this is the axial line. This is the axial line of this bar magnet. ठीक है? So as per the question, or as per this heading of this topic, we have to find the magnetic field at any axial point. You have to find the net magnetic field at any axial point. So let us consider this point P on this axial line, where the magnetic field is to be found for this bar magnet. How to do it? So let us consider this is the axial line of the bar magnet, and let point P is the point. Let P is the point where we have to find the magnetic field due to this bar magnet. ठीक है? Okay. So let us say this point P is r distance. P is r distance from the center of the dipole. Again, let us say this point P is r distance from the center of the bar magnet. ठीक है? If the point P is r distance from the center of the bar magnet, then south pole रू केते distance होबो? Center रू south pole distance is L. ठीक है? हेले साउथ पोल रू पॉइंट पी रो डिस्टेंस केते हबो? माइनस कर दबा r रू L, that is r minus L. Again, center रू पॉइंट पी रो डिस्टेंस is r. Center रू साउथ पोल डिस्टेंस is L. तो r रू L जदि माइनस कर दबा, साउथ पोल रू पॉइंट पी रो डिस्टेंस केते हबो? r minus L. ठीक है? Similarly, north pole रू केते डिस्टेंस हबो पॉइंट P रो? 8 with the distance वाला r, 8 with the distance वाला L. तो टोटल डिस्टेंस कितना हो? r plus L. ठीक है? तो again consider a point P which is r distance from the center of the bar magnet. South pole ରୁ point P ର distance ହବ r minus l. North pole ରୁ point P ର distance ହବ r plus l. ठीक ଅଛି. So let us say B1 is the magnetic field produced by the let us again I'm saying, let us say B1 is the magnetic field produced by the north pole at point P. ठीक है. So let us say B1 is the magnetic field produced by the north pole at point P. हेल तार magnitude केते होबो? That is equal to, that is mu naught by 4 pi pole strength of the north pole, distance of the north pole from the point P, that is r plus l. तो r plus l the whole square. ठीक है. Direction कौन होगा? North pole produce magnetic field that is outward in nature. That is outward in nature. तो let us say इटा को x नहीं जीवा. तो direction होगा along px. ठीक है. Let us say B2 is the magnetic field produced by the south pole at point P. ठीक है. Let us say B2 is the B2 is the magnetic field produced by the south pole at point P. तो B2 ର magnitude केते होबो? That is mu naught by 4 pi pole strength of the south pole, that is m, distance of the south pole from the point P, that is केते distance actually r minus l. So that is r minus l रो whole square. ठीक है. What is the direction? South pole produce magnetic field that is inward in nature. तो point P रे south pole will produce a magnetic field that is inward in nature. तो direction कौन होगा? This is PB लिखी दबा. This is B. तो PB in this direction. ठीक है. Okay. Okay. So B1 is the magnetic field due to the north pole, B2 is the magnetic field due to the south pole. These two poles are anti-parallel to each other. So angle between them कितने आछो? 180 degree. 180 degree. तो net magnetic field at point P कितना होगा? Let us say Bn is the net magnetic field at point P. तो net magnetic field कौन होगा? Is equal to, that is B1 minus B2 or B2 minus B1 रो mod, because the two magnetic field are anti-parallel to each other. So if the two vectors are anti-parallel, तो B net कौन होगा? That is B1 minus B2 or B2 minus B1. जी बड़ थी से प्रथम रहिबो and जी सानो थी से subtract होबो. And the direction is along the direction of the bigger vector. The direction is along the direction of the bigger vector. Again I am saying, if the two vectors are anti-parallel, if the two vectors are anti-parallel, the resultant vector is equal to the mod of the two vectors, and the direction is along the direction of the bigger vector. ठीक है. तो 8 ही if you see this B1 and B2, तो हमें एठी b is inversely proportional to 1 by r square. b is inversely proportional to distance square. ठीक है. So if distance is more, magnetic field strength is less. If distance is less, magnetic field is more. जहार डिस्टेंस कम थिबो मैग्नेटिक फील्ड अधिक थिबो, जहार डिस्टेंस अधिक थिबो मैग्नेटिक फील्ड कम थिबो. तो इफ यू सी b1 and b2, b1 and b2, b2 रो डिस्टेंस सॉरी कम अछि. अगेन when you see b1 and b2, b2 रो डिस्टेंस कम अछि. If distance is less, magnetic field is more. Again, when we consider b1 and b2, b2 रो length टा कम अछि. If length is small, magnetic field of b2 is more. So that means at point P, the magnitude of magnetic field of b2 is more. तो सेति पई b net कोन हबो, that is bigger minus smaller, that is b net is equal to that is b2 minus b1. The direction कोन हबो, the direction is along the direction of the bigger vector, that is b2. तो along bigger vector direction कोन, that is pb, along pb. ठीक है. आउथरे कुछ at point P, b1 direction this side, b2 direction this side, and these two vectors are anti-parallel. यदि anti-parallel थो we have to subtract it. हम से दी जन को हमें subtract करबा को पड़ियो. तो when you subtract the two vectors, so that is magnitude is equal to bigger vector minus smaller vector. तो bigger vector एठी होची b2 and the smaller vector is b1. तो b net कौन होगा, that is b2 minus b1 and the direction is along the direction of the bigger vector, that is along pb. ठीक है. तो b1 कितना हो, सॉरी b2 कितना होची, that is mu naught by 4 pi, that is m by r minus l रो whole square, and this is mu naught by 4 pi, that is m by r plus l रो whole square. ठीक है. तो that is mu naught by 4 pi m common बाहर यू, LCM is r minus l रो whole square, r plus l रो whole square. ठीक है. ऊपर कौन रहा, r plus l रो whole square minus r minus l रो whole square. okay. इठी a plus b whole square minus a minus b whole square, that is equal to 4ab. 4a केते अछि, that is r, b केते अछि l. इठी a minus b, a plus b, तो कोन होबो, that is a square minus b square रो whole square, so that is r square minus l square रो whole square. ठीक है. Okay, तो b net is equal to, this is ये जो 4 अछि एटा को हमें कौन करबा, that is mu naught by 4 pi, that is m into 2l into that is 2r by r square minus l square whole square. एठी जो 4 अछि एटा को 2 into 2 कली. ठीक अछि. फर्स्ट 2 टा l सहित मल्टीप्लाई कली, that is 2l. तो एठी m थिला तो m into 2l, आउ जो 2 रहिला बाहर लिखली, that is 2r, r अछि 2, that is 2r. तो b net is equal to mu naught of 4 by m into 2l into 2r divided by r square minus l square रो whole square. ठीक अछि. Again we know that m is equal to m into 2l. pole strength is equal to magnetic sorry sorry uh, dipole moment is equal to pole strength into magnetic length. तो एठी हमर अछि that is pole strength into magnetic length. तो एठी लिखिबा that is Bn is equal to mu naught by 4 pi, that is m into 2r divided by r square minus l square of whole square. ठीक अछि ओके एटा को एमती भी लिखि परियो. This is 2 mu naught by 4 pi, that is m by r square minus l square of whole square. तो this आउट r छाड़ दे छै. ठीक है. तो we can say the net magnetic field produced by a bar magnet at any axial point is equal to 2 mu naught by 4 pi m r by r square minus l square whole square. Again I am saying the net magnetic field produced by a bar magnet at any axial point which is r distance from the center of the bar magnet is given by Bn is equal to 2 mu naught by 4 pi m r by r square minus l square of whole square. ठीक है. Okay. Again आउ गोटे छोटो जिंस, if it is a ideal dipole, यदि हम गोटे ideal dipole नबा, if the bar magnet is a ideal dipole, again I am saying if the bar magnet is an ideal dipole, तो ideal dipole length टा बहुत छोटा था. तो that means if it is an ideal dipole, L is small. Ideal dipole लो L टा छोटा था. If L is small, L square is very small. चेक करिए. Suppose L is equal to that is 0.1. तो L square केते होबो रे 0.01. तो L टा यदि छोटो था, L square टा आउरी छोटो था. L is 0.2. तो L square केते होबो 0.04. तो if L is small, L square is very small. ठीक है. तो if it is an ideal dipole, L टा छोटो थिबो, L square टा आउरी छोटो थिबो. So we can neglect this term L square in this formula. So neglecting L square term in this above equation, we can write तो Bn is equal to कौन होगा रे, that is 2 mu naught by 4 pi m r divided by r square minus r square whole square. L square को neglect कर देले in this formula, तो रहला कहते r square of L square. Again if L is small, L square टा बहुत छोटो थियो, so we can neglect the L square term in this above formulas. तो L square टा जदि neglect कर जिबा रहइबो कोन r square of whole square. तो that is कहते r fourth रो r कटि जिबो रहइबो कहते. तो Bn is equal to that is 2 mu naught by 4 pi m by r cube. What is the direction? Direction टा लिखिने along, that is PB. एटी मध्य लिखिने that is direction is along PB. Again I am saying when you consider a bar magnet, the magnetic field at any axial point which is r distance from the center of the dipole or magnet is given by 2 mu naught of 4 pi m r by r square minus l square. ठीक है. And the direction is, if P is the point and AB is the magnet, the direction is along PB in this direction, or that is from south to north. If the bar magnet is an ideal dipole, in that case B net is equal to mu naught by 4 pi m by r cube. The direction is along PP, or that is south to north. ठीक है.